In the previous meetings here, we did cover things up to 5, and I realized that not all of us were here last time and on the recording, so I'll quickly go through from 1 to 5, with understanding that if you want more details, you can look there for recordings and pick it up from the help. And I will try my best to complete everything except everything except animations, leaving animations to next week, so that and also next week I will help and assist you guys in preparing slides. Why we are doing these things? Maybe you have already realized that the tasks, not tasks as from humans to humans, but tasks that I needed for this subject always involve advanced level of math that can be either challenging or boring. And this is not math class, and we need to fulfill some ambitious goals. But if you would do everything in old-fashioned pen and paper, it will be like 25% of physical chemistry and 75% of differential equations and calculus, which is quite boring. If we just spend maybe 5–10% of our time in getting the skills, we can replace as much as possible mathematical derivations with running easy scripts, which is overall beneficial and has some guarantee for success. So what else? The helps. So I did send it in the emails, the manuals that are just downloaded from website of Matlab. So if you do not like what is offered here, you can just present starting from looking through this manual. And although it looks like many pages, it's really easy. And it is much easier than our main subject, much easier than any portion of math. So, and there is a version. Let me open it. There was a version from previous. From the previous version of the software, which communicates these same materials, but it is substantially shorter. Feel free to ask any technical questions now or during the week. It is so pleasant and easy subject that I will be ready to answer, hopefully immediately. And let's start going through this stuff. So first one is complex numbers. So Zain and Jared, you may relax. Oh, I have an idea. If so that you do not waste your time, you can either like read news, read emails, do homeworks on other subjects, or if you want to be involved in this, you can just start PowerPoint slides for your presentations. And for everyone, the idea of this presentation is that we help each other, and one attendee of the class becomes expert and help others to pick specific subject. So you can either listen to me and follow what I will be doing on the screen and interact through questions, or just take your subject and explore what to do and make screenshots or copy paste what you see on the screen, and then put it in your PowerPoint slides. Since presentations we agreed to have it in a week and a half, there is plenty of time. But if you have a decent draft today, later on you just polish. So basically, you take your subject and squeeze it into 5 minutes in order to assist your classmates to pick it up and use later for like homeworks. So it works like it's like basically like calculator. You type something you cannot do as a human, and one of the important things is that one can take square root of -1. So if you call it like variable I equals square root of -1, then you can do this I squared, and it will be -1. Please open Matlab and try to follow what I'm doing, so that just watching will not work.
You put in there after the square root of
Yeah. I remember there should be an references, fonts, bold, size 24. I think it will be easier for everyone to watch. So as a calculator, meaning that you can do any operations on numbers, like and get some fractions. So complex numbers, functions, definitions of argument, basic graphics for functions. So one can set up not only one number to one variable, but put square brackets and write set of numbers. And then it will be like an array. So if we want to do something with this array, for example, if you type x period square 2, it will provide, as you see, the squares of each number. For 0, 0, for 1, 1, for 2, 4, for 3, it will be 9, for 4, it will be 16, right? So one can make a set of operations. Also, it is not only discrete set of numbers. One can define, and instead of writing this long line from 0 to 5, I can do from 0 semicolon 5. So it does the same. If I am not an accountant working on counting discrete things, if you need some mathematical, chemical, physical problems, we need discrete numbers, and we can set up the step size. So then it will go by increment. So if I put increment 1/10, then it will go 0, 1/10, 2/10, 3/10, and cover the whole range. In this situation, it is not comfortable to plot them. It's to watch them on the screen. It's better to just plot x. And it shows a set of numbers, and if you want to practice any operation like square, it will plot it as well. So please try doing it, and I'll see if it works. You can just have spaces between them.
Do you have a zero in here?
I wouldn't. O, I used O in the apostrophes for plotting circles.
Okay, so you put an O instead of a zero.
In apostrophes. You can just Alt tab to see another window. What is your? So try to do O dash. And yeah, O dash inside apostrophes. Yes, yeah. Once again, and hope. Okay. And now you have only 3 points. If you have more, it will be more continuous. First, type x equals first begin, first element, column, step, column, last element. And participants, let's check who is, okay. Spencer, if something is not visible, you have questions, please speak. I'll try to check chat line, but it's not always possible.
Sounds good, thanks.
Okay. Functions, definition of argument, basic graphics for functions. Basically, we did it, right? So we can practice different functions instead of x squared. We can type like cosine. And then if you make this trigonometric function. So derivative in finite differences in Matlab. So I can define y equals this cosine. And then let me do a thing that we practiced 2 weeks ago. If y equals x squared. Okay, so what is a derivative? If y is a function, then derivative is limit of y x plus delta x y x divided by delta x, right? So if we do have a list of x's and list of y's, the derivatives will be comparing function at next step and function at previous step, next step and previous step, next step and previous step, right? So if I type diff of this function, look what happened. So 1 minus 0, 1. 4 minus 1, 3. 9 minus 4, 5. 6 minus 9, 7. 25 minus 16, 9. Make sense? So it is exactly what we need, difference of the increments. Now, analytically, what is the derivative of the quadratic function? Bless you, bless you, bless you. What is the derivative of x squared? So it will be a linear function, right? So what if I plot this diff yy? Plot diff yy. So if things are correct, I'm expecting to see linear function, right? So subtraction of previous and next steps will give linear function. So it gives chance to practice derivatives. And if you want to be really meticulous, we need divided by dx, which we can define like in here. Dx was difference between these points, grid points. So it was always 1. So it's basically a derivative. Now, if we can even do some check. No, I think it is fine. If we do so if we use the x with dense points, and you practice the same thing, it still will be linear race. So this stuff that I was just demonstrating, it is a demonstration of numerical differentiation, so numerical derivative. And let me maybe do another example. If we have so what is the let's start with cosine. What is the derivative of cosine? Come on. Derivative of sine is negative cosine, and derivative of cosine is negative sine. Yes, you're correct. So because it goes down. Okay. Now let's do diff cosine x divided by dx. So it goes negative and it is sine. So let me walk around and see that you are repeating this little exercises. Okay. And one doesn't need to retype commands. If I need to repeat the same command, instead of typing it over again, I can just put arrow up and it will bring it last command. If I type up again and again, it will do 2 commands back. Okay. So we have done the derivative in finite differences. Now integration by sum. What is integral x dx? Yeah, I agree. And integration is chopping finding the area under the curve and reproducing it as rectangulars and measuring area in each of those if you have limits, right? So if you do have this quite discrete thing, we can practice the command sum. So sum xx. Let's guess what would we get after I hit enter, or you can make an experiment. So I expect it will add together all of them, and I can just check 0 plus 5, 5, 4 plus 1, 5, 3 plus 2, 5, so it will be 15. Right? And if I multiply it by dxx, which is 1, it will be base of the rectangle, it will be the same. So let's check it with if I take function y equals x, going from 0 to 5, and measuring the area, just graphically, it will be 25 over 2, right? So it will be something like, and if we do integration, it will be the same, 5 squared over 2. So our result differs from this one because we took very rough offsets. What if we do more finer grids? So if I take, you see? So the finer the grid, the closer the answer to the numerical integration. And if we are really, if anyone would do it really for a profession, there are advanced methods which approximate the little areas as either this slanted angle figures or in more complicated functions as little parabolas. But right now we do not need it. So please practice and make sure that you can do this little exercise, and then we'll go further. Did you? Oh, you have. Oh, you are going through installation complete. Very good.
Oh yeah. I put it on my desktop.
What is not working?
I was just messing around with that when I was doing the x-axis.
XX.
Yeah, I was trying to see that it was equal to this. Do I need a space in there? Space in there.
No.
Yeah,
just type XX, enter. Now, now type sum, SUM. No, uppercase, XX. Yeah. Do double X, upper XX. So it's case enter. Okay?
Yeah.
So it's case sensitive.
Okay.
And it's a stupid robot who will not guess what we are thinking. So it's not forgiving. What do we get? Okay, excellent. So right now, today, we are kind of rushing through, but as a preparation for possible remote connections, how will we organize next labs? Well, I hope that we will do in person, but in case it will be remotely, I will not be able to visit your homes and look from your shoulder, but I will just, as a host of the meeting, I will open it, making all of you co-hosts, and I will ask you to share screen so that I can watch what you're doing one by one. It will take a little longer, but basically it will be the same procedure. Okay, so we are done with the first and second. Now vectors in Matlab, Scalar versus Dirac product. Okay, just a second. So vectors in Matlab, scalars versus Dirac product. So I'm out of letters. By the way, if I type who, it will show all variables that I was using. And also on the little panel to the left, it also shows these little symbols for all new variables. If I'm tired of, by the way, if any of these things matches your presentation thing, I would just copy paste stuff and put it into the slides. Like going here, text box, Control V. I'm not telling that it is exactly what I need to do if I present, but if you are thinking about your presentations, just make notes as you do, because you're probably the busiest people in the world. Some of you take like almost 20 credits, so try to optimize your time. Start. Let's continue. So I'm going to erase these variables because I'm done with these functions. So I will type clear. But if you think you will need these variables, do not do it. So after clear, I type who, and there are no variables. Now I'm going to define x as very, very simple. X equals 1 and 2. So very short argument. And I can consider it as very small vector, not as a continuous numbers for calculus, but just as a linear algebra. And if I type x prime, it swaps rows and columns, so it is conjugation. So if I type a equals 1, 2, 3, 4, and then I type a prime, look at here. Just a second. So diagonal 1, 4, 1, 4 stays the same. 2 and 3 swap the order. So transposing works here, and it is related to Hermitian conjugation that we went over in class and we will need later. Now, if we need to multiply matrix by vector, it gives an error. If I do it, why? Because the x was a row vector. But if I use x prime, which is a column, and I do the same, a times x will give another column vector. So I can double check if I was not, if computer is not lying to me. So 1, 2, 3, 4, 1, 2, row by column. Row by column will be 1 plus 4, 3 plus 8, right? So will be 5 and 11, right? So let's go back to, so 5 and 11. It doesn't lie to me. So later on, if I need to multiply bigger matrices, I can use Matlab. Now, what if I use this x without prime and multiply it? So we practice row by column in the way of 1, 2, 1, 2, 3, 4. Row by column. Now there will be 2 elements here and there. So it will be not a column vector by row vector. So 1 plus 1 plus 2 times 3, 1 plus 6, and here row by column 2 plus 8. So it will be 7 and 10. Let's check the same. Scalar versus Dirac product. I went a little bit ahead. I went to matrix transpose and matrix multiplication. So what if I multiply x prime times x? What I'm going to get? 5? No. If I multiply row by column, then I practice the one, 2 times 1, 2 equals 1 plus 4 equals 5. Right? Scalar product by elements. But this, so we convert 2 vectors into 1 number. But if one swaps the order of row vector and column vector, you see it gives us something different. So if I do this row by column, it gives a number. If I do column by row, it gives a matrix, right? And this is the consequence of literally following row by column rule. So if I do row by column here, it will be 1 element, 1. nothing else to sum. Now row by column for this, for the next element, it will be 1 by 2, 2. If I do row by column here, it will be 2 by 1, 2. And if I do row by column for last element, it will be 4. So 1, 4, 2, 2. Make sense? So the stuff on the previous slide, it is a scalar product of vectors. And the one, when one do this corrupt, crazy swap the order, it is dyadic. So please practice it. I'll walk around. Very good. So if the elements that you are trying to run do not match row by column, then it will give an error. Okay. So we got vectors, scalar versus dyadic product, Dirac notation. Okay, yeah, Dirac notation is, so use black number. So when we have column vector, one uses it as a angular bracket facing to the right. When we do have row vector, we use angular bracket facing left. And if one multiplies row by column, it is left and right matching together. This naming of x comes from the English words bra and cat. So when they will do something interesting and complete when they match together. And this notation is used to unify both vectors and continuous wave functions. Right now we speak about vectors, but we can apply the same for wave functions. And when we multiply bra by cat, we get a number. We remove wave functions. We come to a space of real numbers. If we, so column is cat, row is bra. If you multiply cat by bra, then instead of number, one obtains matrix if we speak about linear algebra or operator if it is quantum theory. Okay. We are done with number 3. Vectors, scalar, dyadic, Dirac, matrices, transpose, determinant. determinant A minus 2. So the one, two, three, four. Determinant is diagonal minus subdiagonal. 2 times 3 will be 4 minus 6 minus 2, right? So why this construction is needed? Originally, matrices were introduced by bankers in Venetian Republic to make debts and credits, and they needed to solve linear algebraic equations. And before one starts to solve equation, one needs to know whether it will have a solution. So determinant tells whether the linear algebraic equation composed with this matrix will have solution. Basically, is it good or bad matrix? So it's a quick criterion. And you can see if you type DET and then matrix, you get the number, which we assume to believe. I'll not go a circle because it should be quite simple. Now, what if we multiply matrix by unknown vector? I just want to clear once again and put, I will need the same matrix, but 3, 4, but I do not need the vectors. So if I multiply known matrix by unknown vector and get another known vector, then there is a need to find the elements of the vector, and it looks like a system of algebraic equations. One can solve it by introducing inverse matrix with the property that inverse matrix by matrix itself will give unity matrix, right? So if one knows the inverse matrix, then one is obtaining the solution of linear algebraic equation. So inv A, I can tell maybe B equals inv A. So, and now if I multiply B times A, it generates matrix with ones on the main diagonal and zeros on the off diagonal. So it is inverted matrix. Make sense? Please try to do it. And now, if I so if I set up this C free term as 1, 2, X, which is unknown, will be just X1, X2, and this A will be 1, 2, 3, 4. Then after we get this inverted matrix B, if you multiply B times C, we should get X. And example is here. So C b times c is 0 and 1/2. And if this is, I can even set up it x equals. And if this is correct, then a times x should be equal c. Or a times x minus c should be equal 0. Make sense? Let me know if I need to scroll up or down, and I'll check what you guys are doing. No bracket. When I was defining C, I was using only one opening bracket and one closing bracket. So you open, then you can do either row or column. I was doing column, and then at the end the closing bracket. So for one stuff. Excellent. Jared and Zane, how are you doing? Reading news? Reading news, relaxing, or doing something? You deserve it. Try to, if you are dealing with Matlab, yeah, try to find like movies, how to do it. They, if you look through help and demonstrations, try to vibrating logo. 30 years ago, they were proud of this movie, and they thought it is accomplishment because it is a little problem that is not possible to solve analytically. So if one considers a drum where the shape is not circular, but L-shaped, like curvy, then there are no mathematical functions that will give answer how the surface of this drum will vibrate. And they show how to solve and demonstrate it. Today is not something spectacular, but when the Matlab code was originally introduced, it was like glowing achievement to brag about. We are done with basic operations with matrices, and we are just one subject behind Zane and Jared. We need to find eigenvalues of matrices. Let me check if it is really so. Yes. Oh, we can do visualize a matrix, but it's quite simple. I'll do it instantaneously. So eigenvalues, and I do need insert. I do need empty slides just to make notes. So just a couple of minutes ago, we considered linear algebraic equation. So it is one equation, one solution, so one vector. But if you do have a problem of this shape, a times unknown vector x equals, so this one, I'll make it maybe fat, a equals a number, lowercase, and it is equals vector again. So such problems do have more than one solution. And it is a type of problems like time-independent Schrödinger equation that we do solve in class, right? So if it is, again, I do not want to spend time and be in general. If x is unknown and a is our example 1, 2, 3, 4. It means that 1, 2, 3, 4 times x equals, and one can introduce everywhere the unity matrix. It will not change anything. So equals letter A, which is also unknown, 1, 0, 0, 1, x. So now we do have matrix on the left and matrix times vector on the left and on the right. And if you subtract from left part, we subtract right part, or translate left to the right. On the left, we will have subtraction of these objects, and on the right, we should get 0. So 1, 2, 3, 4 x minus a 1 1 1 0 0 x equals 0. It should be like 0 vector. And now we can put the unknown vector outside of brackets, and then it will be subtraction of two matrices. So, and here the A goes here and there. So 1 minus A, 2, 3, 4 minus A, x1, x2 elements of the vector equals 0, 0. So by solving such equations, one will find several values of A and several values of x1, x2. This is called Eigenvalue Problem. This is a main problem. Most things in quantum theory are reduced to this one. And main feature of this problem is that more than one solution. How does one solve this equation? There is a theorem that this identity will be correct if the determinant of the matrix on the left is equal to 0. So diagonal minus off diagonal. Four minus 5a plus a squared minus 6 equals 0. A squared minus 5a minus 2 equals 0. So the matrix equation is reduced to polynomial equation. And by finding the roots of this polynomial equation, one is getting eigenvalues. Did you have it in previous courses like linear algebra or calculus? Then I'm feeling happy that I'm bringing something important. Another thing I always forget to announce: whoever finds errors in whatever I tell gets points and extra credits. So by human weakness and human nature, I'll do mistakes and errors. Please stay alert and try to catch them. So if you do not see any errors here, what would be the solution for this? Do you remember how to solve quadratic polynomials? Do you remember the equation? So what should I write in the square? B squared minus 4AC on the denominator, 2A. And is it minus B at, here? Okay, let's plug in and see. So B is minus 5. So minus B is 5. 5. Then plus minus square root of 25 minus 4. A is 1. C is minus 2. So it will be plus 8 divided by 2. So 5 over 2 plus minus square root of 33. So square root of 33, it will be approximately 6, right? Like 5 point something, 5.7, or 12 over 2. So something like 5 over 2 plus minus 12, or let's put 11. I'm just trying approximately. So this minus, it will be minus 6 over 2, about minus 3. And second solution, 5 plus 11, 17 over 3. So it will be about plus 8. So if I didn't make errors, and if we repeat this procedure with Matlab, we should get something like that. So this syntaxis corresponds to solving eigenvalue problem in Matlab. And now we are approaching the same level as Zane and Jared did a week ago. Probably I did some I did screw up in analytical, but according the let me show here. So D shows eigenvalues on the diagonal. U shows eigenvectors, and according to this calculation, there is one negative, one positive, and the negative is about minus 0.4, and positive is 5.4. Let's check it, how close or how far it is. It looks far. Probably I miscounted something. So it gives you chance for catching my errors. But let me complete the thing, and then we'll go further. At least Zane and Jared didn't. I was doing slightly different example, and last time either I was more correct or they didn't catch me. But it was not, the sound was not recorded, so we cannot prove it in the court. So the elements in this U vector, so the columns minus 0.8, 0.5. Let me just copy paste it here. Control C. Control V. So the elements here will be first solution. The elements in the second one will be second solution. And the numbers in the matrix D. So first element will be eigenvalue number 1 or eigenvalue plus, and second will be eigenvalue minus. So by matching together first eigenvector and first eigenvalue, or second eigenvalue and second eigenvector, one would convert the original equation into correct identity. So I'll try to catch errors myself, or you can catch and communicate to me. So please practice this EIG and see what happens. So these you already have it. Okay. So let's look at the original plan. So Jared. Oh, okay. He will tell everything in the correct way. You remember it from last time, and you'll be presenting eigenvalues. Please do it better than I did than I performed today. Okay, thank you. So done here. Now, two-dimensional plots of one-dimensional functions. Oh, okay. 3D plots of 2D functions. Sure. This should be quite simple. So let's set, okay, I'll clear everything, set up X as just range from 0 to this small step to maybe like 12. Then making the Y of the same range just in case. And if I do function Z equals sine X, we already did it. Then I do plot X comma Z. We just plot this sine function. So it is two-dimensional plot because it is planar. It's the most basic thing. And if one explores the options on this figure panel, so one creates an arrow, then clicks on the line, and then double clicks, there would be an opportunity to modify format, like line style, dashes or dot dashes, line width. Now it is 0.5, one can do it 3.5, so it will be thicker. Before we did a circle symbol like a marker, but one can play and do like diamond or square, whatever is available. We have hexagram, pentagon. So one can change this stuff. If we do productive figure for like report or publication. So now I'm clicking not on the line, but on the area near the line, and it shows an opportunity to change the font size. So instead of 10, I can put bigger. So it has this larger fonts. And there is another thing that I can do in a command line. So I can type X label, X, and I can type anything I like. So now it shows the stuff that I want back here. And I can put Y label and type if it is a function. Right now it looks quite childish, but if by some reason we need to generate several figures with a scientific importance related to the class, then figures without labels will be very hard to navigate through. Even if I do 1, 2, 3, 5 figures, I can keep all information in my head. If I do 20 or 100 figures, I hope we will not do it in this class, but in the future, everything should be labeled, even if it looks childish. And with time, you may learn some additional fancy things to make it visually appealing and how to say, if you need to live by making figures, you can learn how to improve the quality. But thickness of a line and font, it looks childish, but it is really important. Okay. Please practice it, or just make a quick trip to see if you don't need to clear. Then you need to redefine things, but just a little warning: do not literally follow what I'm doing. If I do some crazy stuff, do not repeat my errors. Super. So while you're practicing, I'll check that we are here, and we are done the first part, two-dimensional plots, and then we'll do. And we did. I skipped the background, but whoever presents it will need to check how to change the color of the background. We changed the size of the font and line thickness. We didn't do color, but it kind of easy. So now we need to do two-dimensional functions. And then if you take the, well, yeah, you may type. And then try to play by clicking with the figure. Just selecting this arrow and clicking on different elements of the figure to edit it. And if while preparing it as a presentation, one may learn how to print screen or import figure from Matlab to the PowerPoint. So if I want another figure, if I like the first one figure, there will be second figure, and I can instead of plotting things, there is a function bar which should work as a histogram, just putting little arrows, not arrows, but rectangles. So now if I design function as, let's say, sine x times cosine 2y, no error, and size of w, no, so if I define function that does depend on two arguments, and here do not forget this apostrophe, there are other ways to define two-dimensional functions, but if it is really things that depend on two arguments, like a big matrix, or if we define it as a function, then matrices and two-dimensional functions can be plotted by either one of these three-dimensional commands. So one is mesh, and here is the symbol of rotation. One can look around from different angles. And in addition to mesh, there are commands like contour. If you would have a very old-fashioned weak computer, it represents this two-dimensional function just as a geographic map, like contour lines where it is higher or lower. There is also code waterfall. Where it makes horizontal lines along x-axis as a set of one-dimensional figures. And if one is looking for help mesh, it will be some additional statements what it is. And basically for any command we are doing, one needs to type this help. And if you need to learn more. In addition, they have advanced mouse-operated help that you can find, and also they have a demonstrations for some popular things. You see, if it prompts, if I was asking help for the mesh, I also need to read about waterfall and surf. Let's check what is surf. Surf W. So it will make it more like painted. I'll make a quick tour, seeing what you're doing, and the impact, the necessity to do these things is as follows. Suppose we do have a computer code to illustrate what we're doing, what we were doing today in class. The propagation of electron in space and time. Then wave function or probability distribution depends on two functions, two arguments, space and time. in order to represent it on graphics, we need these three-dimensional figures. So basically, we'd look for probability distribution with one axis being coordinate, another time. So we will use these commands again and again. Okay. Very good. And there are a few more commands, like I think there should be bar 3, where it discretizes, and if there are so many arguments, it doesn't look nice, but if it is just matrix of like 5 by 5, it makes little sticks, parallelogram sticks upwards, showing how big the element of the matrix it is. And if we do have let's see, do not type clear after me, maybe it is not needed, but if I do x going from 0, 12, y equals cosine x, z equals sine x. So I have one argument and two functions. Plot, let me make new figure, and then I can do plot 3 of x, y, and z. So it will show the coil where x is the argument, then y projection is sine, y is cosine, then together it shows like this helix spiral. And I think on one of the previous meetings with Zane and Jared, we were doing the same with complex plane. Here I just defined it as sine and cosine. But this three-dimensional, oh, there is a chat. Let me check who is chatting. I'm going to leave early. That's fine. That's fine. Yeah, that's okay. See you in class, Spencer. And I plan to send the recordings sometimes after midnight. Yeah, you have a great night, you too. Okay, so I'll please try to practice this three-dimensional thing, and then I will move to the saving data. No. I'll leave it for a little. Write Matlab variables into file. This is the first thing I will do. So let me check if you have this three-dimensional coil. Plot 3. Just type plot 3. Plot 3. Open bracket. Round bracket. Not round bracket. X, Y, Z. Close the bracket, enter, and look on the figure. Okay. Yeah, super. So you noticed me doing this clear. So if I do save just without any arguments, and then I do clear. Oh, first I do who. Who, it shows variables. Now I do clear, and after that I do who, it shows no variables, and the panel on the left shows nothing. Now I do load, and it brings variables back. So it reads from the disk space. This is the like easiest thing. just to save everything. Now, if I need to save specific variable under specific name, for example, I want save variable y, which will be just a list of cosine values of cosine. I can type save minus ASCII y. All lowercase. So it doesn't show error. And this command saves variable y into the file named y and then I type pwd, which is pathway detection, into this place of the disk space. So I may check what it is. Documents, Matlab. You see there is a variable y, and I can open it. Open this. No. Txt. y.txt. Y. Let's do it this way. So I slightly adjusted. So I typed y.txt. So the name of the file will be y.txt. And now in this directory, I see text file. And if I open it, it will contain this data. So basically, if you compute something valuable and you need to export it into the Microsoft Excel, you can save file and then import it back into Microsoft Excel, right? By the way, if I do prime here, no, it doesn't want to do it. Okay, let's do y1 equals y prime. Y prime, y1. It works. Now I do have this yy variable which arranges data in the column, which is a little bit better for importing into Microsoft Excel. Now, if I'm not confident in my own memory, I can do help save. And it will give all details which could be exceedingly long. But it will explain all this stuff, and in a free time I may read it. So minus ASCII means to save it in the text format that can be readable later. Now, after suppose now I clear everything again. Clear, no variables. But now I decided that I need to read. Maybe my colleague, one of you, created some data that I want to read and process further in Matlab. So I can type y1 equals load y1.txt. And now you see on the left, there appears something is available. If I type who, there is a y1. If I type y1, it shows this set of data, and I can plot it right away. So at this point, we do some childish things, but later on, we can generate data that are not like computed with advanced procedures and have some valuable meaning. And then maybe transferring of a data from one person to another one is more meaningful than recomputing it. Okay, please try it. And I think now Jared and Zane can join us and try to practice this command as commands as well. because it's quite easy, but it's better to have them practiced. And this loading and saving of data is the first step towards programming. You didn't say, you cannot read it before you save it. First, you need to save. Did it work? Yeah. Okay. Did it work for you guys to? Yeah. Okay. So, were you able to open this little data file with text editor or Excel? Were you able to navigate where it is on the disk space? Yes? Oh no. Let me show it once again. It's easier to show than to speak. So if I type PWD, it shows the path where is the directory to which I'm working, saving. So if I go, so it is users, then username, and then documents and Matlab. If I go to file browser, documents, Matlab, and then it is these files. Okay, good. Whew. Load, save. Write Matlab variables into file, read from file. Done here. So Zane is clear except the movies. Scripts. August have some circumstances. If he will not be able to present at a time, we'll split maybe his subject between others. But let's slowly start it. Let's design some simple problem to which we may need programming. And of course, keep. Suppose we do not have the command of summation that we already covered today. Suppose we do have a set of numbers going from like 0, 1, 2, 3, 4, 5, and we need to add all of them together. So just if this sum command is absent. So we need to go over each of the elements, just list them, and then let's call them x1, x2, x3, x4, x5, x6, and then we make variable that we will call sum, and we will make sum equals x1. Then on the next step, we can tell sum equals what it was before, sum plus x2. Then on the next step, we'll do sum equals sum plus x3. And then we will repeat it as many times as we need it. Make sense? Looks like programming. So in Matlab, there is an option for a script, like new script. And by now it is untitled, but I can immediately, while it is blank, save as. I will call it maybe my sum dot m. So it will be my attempt to do some command. Now, if I want to count numbers from 0 to 5, then if I just type, it should give this number, and I type end to end the cycle. Let's check if, and then I save. And here in the command line, I can try to execute it. My sum. So look what it does. So after I type my sum, it shows I equals 0, I equals 1, I equals 2, I equals 3, I equals 4, I equals 5. Make sense? So by now you do have, and please practice it as we speak. So this cycle just goes over repeating operation, right? And I can do some silly operations that I do not really need, but I can type x of I equals I. So it will be basically as we define the x variable. And if I do not, if I put semicolon, it will not show I, but it will show x of I. So save my sum, and it gives errors. So if one tries to do some coding, it will give errors most of the time. Let's do x equals empty and check if it works. Okay. Just in case, so this was populating the array X. So originally it is empty, then it put 1, 2, 3. So it made basically the same thing as we were doing in command line. Now I can define the variable sum and set it to be 0. Then inside the cycle, and I can type sum equals itself plus, let's say, I, just value of this thing. And I can remove the semicolon and see what happens. Save. So as we go through the steps, originally it is 0, at next step it is 1, at next step it is 3, at next it is 6, then 10, then 15. And x equals this much, sum of x equals 15. So basically we reprogrammed the sum command, which we can use for numerical integration. I'm not telling that it is something, some big breakthrough in the computer science, but just little hands-on things. So let me walk through and see if it was working on your side. And this stupid robot is not forgiving. If you use uppercase and lowercase, it will not recognize Okay. Did it work? Okay. Very good. Makes sense. You think it is enough for today? So from now on, you are certified programmers. There are a few more comments, and by the way, if you need to, you can type help for, and it will tell all possible details how to program this stuff. And during the cycle, at the end of the script, one can save data in the file and then later analyze it with Microsoft Excel. Basically, it is what we will be doing later in the class for the project. Let's check if you have anyone. No one is online. You have only us. Any questions, objections, or suggestions? Okay, then let's announce completion of the class for today. Looking forward to see you on Friday, and thank you for your active participation and patience with all this stuff. I believe you will be, well, everything what we do is a kind of load on your busy schedules, but at least inside the course, we take some shortcuts and we will replace complicated math with easy programming. Done, and I'm going off record. Stop sharing.
Thank you.
Oh, thank you.